I wanted to make a short tutorial on the steps to solving word problems with the current topics that we're covering with angles and angular velocity and that kind of stuff. So what I did was I wrote out some steps to solving those word problems. 1, read the problem. 2, draw and label a diagram showing the given information if at all possible. 3, identify your unknown, in other words, what you're solving for. 4, identify the given information, and sometimes you're going to have to make certain assumptions based on prior knowledge about your given information, and you'll see some of that in the example that I did. 5, determine the formula that will solve for your unknown using the given information. And 6, you're going to substitute in the given information and solve for the unknown, and you're going to include your numbers and your units to make sure that it makes sense. So the example that I chose was page 368, number 91, and the problem reads, the minute hand of a clock is 6 inches long. How far does the tip of the minute hand move in 15 minutes? How far does it move in 25 minutes? And so the first thing that you need to do, which I just did, is read the problem. Then you're going to draw and label a diagram showing the given information if possible, and it's very possible for this problem. So I have a clock that I drew as a blue circle. I don't care about the hour hand, I extended the minute hand up straight to 12, and that's 6 inches. And then I have an arc showing the movement of the minute hand, and I redrew the minute hand. The angle, which is a 90-degree angle, is theta. And then the arc length, which is what we're trying to find, really, the arc length of the movement of the hand is S. So step 3, identify the unknown, which is what you're solving for. And in this case, I'm trying to find the arc length, which I represented by S in the diagram. Identify the given information. Well, you know that that's a 90-degree angle. And what we're going to do is we're going to convert theta to radians. And I'm not going to go through that conversion, it's really easy. But based on what we did in class, we know that theta is pi over 2. And that's 90 degrees converted to radians. If you have a problem with that, email me and I'll show you how to do that. One quick way to think of it is 180 degrees is pi radians, so 90 degrees is going to be half of that, or pi over 2 radians. And r is 6 inches. So I've got the given information, I've got what I'm looking for. I need to find a formula that I can use to help solve that. So I'm going to use this formula right here. S equals R times theta. That's one of the formulas that we went over in class. You're going to substitute in the given information and solve for the unknown. And you need to include your numbers and units. Remember, you need to convert theta to radians in order for this to be to successfully use this formula. S equals R times theta. S equals, after you substitute in the given information, 6 inches times pi over 2. S equals 3 pi, which is approximately 9.4, and then your units are inches. S equals 3 pi inches, which is approximately 9.4 inches. Remember, when you're working with radians, you don't include that units. It's understood that you don't write down the units radians. You would write it down if it was degrees, but you don't write down radians. For the second part of the problem, the only difference is that theta is not based on 15 minutes, it's based on 25 minutes. If 15 minutes is 90 degrees, that means that 1 minute equals 6 degrees. Therefore, 25 minutes equals 150 degrees. And you can use a conversion where you have 15 minutes equals 90 degrees to figure that out. So if 25 minutes is 150 degrees, this conversion I did out right here, 150 degrees over 1 times pi radians over 180 degrees. You eliminate the degrees, you simplify your 150 divided by 180, and you end up with 5 pi radians over 6. So S equals R times theta. R is still 6 inches, but this time theta is 5 pi over 6. So S equals, when you multiply that out, the 6's cancel, and you get S equals 5 pi inches, which is approximately 15.7 inches. That means, going back to the original problem, that in 15 minutes, the tip of the second hand is going to move 9.4 inches approximately. And I didn't draw it, but if you had the second hand down here, which would be at 25 minutes, the tip of the second hand in 25 minutes will have moved approximately 15.7 inches. You can use this method to work on all the problems that I assigned you in class today. If you have any specific questions, email me and I'll do my best to respond.